Hello. Today we'll discuss construction of regular grammar from finite automata. Now to construct this regular grammar from finite automata, we need some idea how we can construct this regular grammar. So for this, we consider suppose we have a machine that M where the attributes are suppose Q0, Q1 and some state Qn, and sigma is basically input alphabet, transition system delta, q naught is the initial state and f is the state of final state. Now if w is any string is in the transition system of finite automata of the machine M, then it is obtained by concatenating, that is this w, it will be obtained by concatenating the labels corresponding to several transitions, and it will start from q naught, starts from q naught, and then last terminating at some final state, terminating at some final state, final final state. So for the grammar, suppose we are going to construct the grammar G. So for the grammar G to be constructed, production should corresponding to this transition. Also, there should be provision for terminating this derivation on say transition terminating at some final state is encountered. So with this idea in mind, we construct G as suppose Z is equal to A naught, A1, AN, AN. So these are basically non-terminals, and then suppose sigma is a alphabet, P is the production rule, and here A naught is the starting symbol. So what is this? This is basically the V of N or non-terminal. And now we define the production rules. So where P is defined as number one, we define the transition production rules AI to small a of aj, and this production rule belongs to the P if that is a transition qi. By taking the input a, it will go to some state qj, and this qj does not belongs to the final state. And number two, this production rule ai to a aj and ai to a, this will belongs to the production rule of the grammar G if there is a transition from qi. By taking the input, it will go to some state that will belong to the final state. Rather, we can say that this transition, whatever be the output state, that belongs to the final state. So by this idea, we can construct a regular grammar from a finite automata. Now we'll take an example. So example 1, construct a regular grammar G generating the regular expression suppose 0 star 1, then 0 or 1, it's star. Yeah. So first we need to do, we have to construct a finite automata corresponding to this regular expression. So what will be the regular expression what will be the finite automata corresponding to this regular expression? It will be, so any number of 0. So the smallest string from this expression is 1, right? So 1 alone will be accepted, then 0 1 will be accepted, 0 0 1 will be accepted. Similarly 1 0 will be accepted, 1 0 0 will be accepted, 1 0 1 will be accepted, 0 1 0 accepted, 0 1 1 1 will be accepted, and so on, right? So that means 1 1 is the smallest string that will be accepted by this automata, finite automata. Now, so if we draw the transition diagram, it will be look like this. So 1 alone will be accepted, and it is a suppose final state qf, and it is q naught is the initial state. Now any number of 0, so we can write 0. So 0 1 0 0 0 0 1 and whatever will be accepted. Now after 1, any number of 0 will be accepted, any number of 1 will be accepted, the combination of 0 1 will be accepted. So the transition system will be this. Now the regular grammar G corresponding to this finite automata, so the regular grammar G corresponding to this finite automata. First A, what are the different production rules? So go to the rules. AI to AJ belongs to production rule if there is a transition from QI to, by taking A, it will go to some state QJ which is not a final state, and here A is the input symbol or sigma, that is alphabet, and A0, A0, A1, A2 dot AN are basically the non-terminals. So from here, from Q naught, by taking 0, it will be in Q naught. So that's why if we consider that as there is a two state, so obviously we can assume that Q naught corresponding to A naught and QF is corresponding to A1. We consider these two states, two non-terminal. So A naught to 0, A naught will be there by using the rule number 1. A naught to, it will go by taking 0, it will go to same state. That's why we have written A naught to A0, A naught, as there is a transition that Q naught, by taking A, it will go to some Q naught. Or we can write the reason on the right hand side why we have written this, because there is a transition Q naught, by taking A, it will go to some state Q naught. That's why we have written this. Number 2, B. For B, from Q naught, by taking on, it will go to some state QF. So we can write A1, A naught, by taking 1, it will go to some state A1, and A naught to 1. Why these productions? Because there is a production transition Q naught, by taking 1, sorry, it will be 0, it is 1, it will go to some state QF, and this QF belongs to the final state. That's why there will be, by using the rule number 2, this rule number 2, so this production will be there. So as from Q naught, by taking 1, it will go to some state QF which is a final state. So there will be two production rules. So one is the A naught, by taking 1, A1, and A naught to 1. Number C, from QF, by taking 0, it will go to QF. So A1 by taking 0, it will be A1 and A1 to 0. Why this production? Because there is a transition QF. By taking 0, it will go to some state that is a QF, which is a final state. So that's why two production rules. Now another production rules will be there by taking A1 by 1, A1 and A1 to 1. Why this production rule? Again the same reason. Del from QF by taking 1, it will be QF while belongs to final state. Right? And in the first case, this is a Q naught and which does not belong to final state. That's why we have written these transitions. Right? Now, if we combine, so all the production rules we have obtained. Now, finally, we can write, so the grammar G, regular grammar G, where A naught and A1 are the two non-terminals. This is N, and two input symbols are 0, 1, and production rule P, and A naught is the start symbol. Where P or the production rule is given A through D. All the production rules will be there. Okay. Now we will discuss transition system from regular grammar. So here we are given a regular grammar. Now we want to design a transition system. Okay. So here also we assume that let G be a grammar where A naught, A1, AN are the non-terminals, sigma is the input, P and A naught is the input start symbol. Now we construct a transition system M whose number 1 states corresponding to variables, right? State corresponds to variable, okay, or variables. Number 2, initial state corresponding to A naught. So initial state correspond to A naught. Number 3, transition M, transition in M corresponds to productions, in P of the grammar. Now, as the last production applied in any derivation of the form AI to A, any production, so as the last production applied in any derivation of the form AI to A, the corresponding transition terminates a new state, and this is the unique final state, right? So we define M. So we define M as how? Q naught, Q1, Qn, QF is the final state. Then sigma, del, Q naught and QF is the final state. Because this transition function, this M is a basically finite automata where these are the states and these states are corresponding to variables. And QF is the final state, sigma is the input alphabet, delta is the transition function, Q naught is the initial state which is basically correspond to the A naught of the grammar, non-terminal, and QF is the final state. So we define this M as by using these tuples where delta or the transition function is defined as number 1, each production AI to A of AJ induces a transition from QI to QJ with level A. Okay. And number 2, each production AK to A induces a transition from QK to final state QF with level A. So these are the two rules how we can construct a transition system corresponding to a regular grammar. Now we will give an example. Suppose example 2. So consider a regular grammar G given as A naught comma A1. Input are 0 1, production are given A naught to 0 A1 comma A1 to 1 A1 comma A1 to 0 comma A1 to 1 A0. So these are the set of production rules with A naught is the start symbol. Yes, A naught is the start symbol. Okay. Now we have to construct a transition system M. We have to construct this transition system M which accepts the language that is generated by these grammars. Okay. Now we have to construct this transition system. Okay. So now as so from this production rule we have to start. So first, as there is a production of the form A naught to 0 A1, so it means we consider that Q naught and A1 is basically Q0 and Q1. We consider it is a Q naught and it is a Q1. So it means basically there is a state Q naught. So from where by taking input 0, it will go to some state Q1. Go to this rule. Each production AI to AJ induces a transition QI to QJ, A0, A naught corresponding to Q naught and AJ is corresponding to QJ. So we can consider that A1 corresponding to Q1 and with the label A. So we have written this. So as this is the production rule, that's corresponding transition diagram will be this. Now A1 taking 1 A1, right? So which basically induces Q1 to Q1 by taking 1. Now the production rule A1 to 1 A naught, it means from Q1 by taking 1 you are in Q naught. Clear? Now A1 to 0. So when this production rule are there, go to this rule number 2. Each production equal to A, only that is on the right hand side, there is a terminal. So it induces a transition from QK to QF with level A. So it induces from Q1 to final state QF with level 0. Now we combine all these transitions to a single. So if we combine all this to a single transition diagram, it will be look like this. So Q naught, Q1, QF, and it is a final state. It is the initial state. So now from Q naught by taking 0, it will go to this 0. From Q1 by taking 1, it will be in the same state as a loop. From Q1 by taking 1, it will move to Q1, and from Q1 by taking 0, it will go to some state, final state Q. So this is the corresponding transition system M corresponding to this regular grammar G, right? So finally we can write the machine M is basically equal to how many states are there? Q naught, Q1 and QF, right? And inputs are 0, 1, delta is basically given uh, delta, and Q naught is the initial and QF is the final state. We can write it is a single state. So this, where Q naught is corresponding to A naught, Q1 corresponding to A1, and QF is the final state, and whose transition we can write in this way. Delta can be written in that way. So del Q naught by 0, it will move to some Q1 and so on. Rest of the transition function or delta can be defined in this way, right? So these are the two concepts that we have discussed today. One is regular, we have to construct a regular grammar, that is from a finite automata, and then we have discussed transition system from regular grammar. So thank you.